Look closely at the world, and you will notice a hidden pattern. The heights of human beings, the errors in a factory machine, the distribution of grades on a test. They all secretly follow the exact same mathematical shape. The shape of chaos. To see it, we use a random variable. This is simply a rule that maps an unpredictable event to a number. Instead of just flipping coins, imagine measuring the exact height of thousands of people. Height is a continuous random variable. Because it is continuous, no two people are exactly the same height down to the microscopic level. So, the probability of finding someone exactly 6 feet tall is actually 0. Instead, we measure the probability of a range, using a probability density function. When we plot these probabilities, nature does something incredible. Most people cluster around the average, and extreme heights become exceedingly rare. This creates the normal distribution. The bell curve. It is the undisputed king of statistics. But reality is rarely limited to just one variable. What happens if we map two random variables at the exact same time? Say, the height and the weight of a population. Let's step into the third dimension. This is a bivariate normal distribution. A 3D probability surface. The peak of this mountain represents the most likely combination of our two variables. As you slide down the slopes in any direction, the probability drops exponentially. By calculating the volume under this 3D mountain, data scientists can predict everything from weather patterns to financial market crashes. Next time, we will explore the central limit theorem, and why everything in the universe eventually becomes a bell curve. Thanks for watching.